All right, guys, we are in activity 4 now. So today in 4-1, we're going to do this in a couple days here. So in day 1 today, what we're going to be doing is evaluating piecewise functions for a given value of the domain. Okay, so make sure you have the 4-1 note sheet attached in Google Classroom, something to write with, and a calculator because we are going to be doing some evaluating, so you might want that calculator handy. So here we go. Okay, so before we actually evaluate piecewise functions, let's talk about what a piecewise function is. Okay, so a piecewise function is a function that is defined using different rules for different intervals of its domain. So I'll give you a second there to write that definition down. Okay, but here's a picture of what we would call a piecewise function. Okay, so we have what they call different rules. Okay, that implies that these different function rules that they're talking about, so how we kind of approach the function and what the function looks like and acts like. Okay, so those are the different rules. Okay, the domain restrictions are the intervals, okay, of the domain. Remember, domain is all the x values. Okay, so it's two different function rules in this case, since there's two equations. Okay, and we restrict it based on different domain restrictions. So anytime we have an x value that's less than or equal to 0, we use this function, the x squared minus 3. If we ever have x values that are greater than 0, okay, like 2 or 100, okay, then we would be using this function rule. Okay, so a piecewise function is just kind of what it sounds like. It's a function in multiple pieces. And when we use each piece is determined by this restricted domain. Okay, so we're going to start by doing some examples here. So I have two different piecewise functions that we're going to start with. I have f of x and I have h of x. Okay, so that'll come in handy when we actually start doing the problems. As you can see, I have like f of 4 here and then like h of negative 3. So that's going to tell us what function we're using. So if I look at this first example where it asks us to find f of 4, call this number 1, okay? F of 4 means that I need to plug in the function for f, so I'm going to be using the green function. And the domain value they're telling me is what is the function equal to when x is 4. So they're giving you an x value to plug in. So what we have to do is look at that domain restriction, this right here. And we have to decide what function we're going to use, which piece of the function, okay, based on that restriction. So the number they gave me is 4. So we just have to decide, is 4 less than or equal to 0, or is 4 greater than or equal to 0? Well, hopefully you decided that 4 would be greater than or equal to 0. So we're going to use that function to plug into. So I'm just going to recopy the function this time. I might not do this every time, but so wherever there's an x, we're going to substitute in the value that they gave us. They told us to find f of 4. So I'm going to plug that in. And then we just kind of do our order of operations to solve it out. So half of 4 is 2. 2 minus 1 gives me my final answer of 1. Okay, so a lot of evaluating piecewise is just deciding which function you're actually substituting into. Okay, so let's look at the next one, f of negative 3. So if it's f of negative 3, are we going to be plugging into the f of x equation or the h of x equation? Okay, well, hopefully you said since it's f, we're going to use the f equation. So I'm going to be plugging in over here. So if it's negative 3, we just have to compare that with our domain restriction. Is negative 3 less than or equal to 0 or greater than 0? Okay, so that would be, since it's negative, we know that's less than 0. So what I'm going to do is plug that in for x in the top equation. So it'll be negative 3 times 2 plus 3. So that's negative 6 plus 3, giving me a final solution of negative 3. Okay, so you're only ever plugging into one function or the other. Okay, so you're never going to be plugging into more than one. You just have to decide which function you're actually going to use. All right, let's do the next one. The next one has h of 3. So h of 3 implies that I'm going to be using the h of x function since it asks me to find h. Okay, so if that's the case, now I just have to decide which function I'm using. This one technically has 3 different values. So if it's h of 3, where does that fit in? Is h of 3 less than or equal to 2? No, right? Is 3 greater than 2 but less than 4? So is 3 in between 2 and 4? Well, yes, it is, right? So that means we're using this bottom or this middle equation. So we have 4 minus x that we're going to use as our function. So if I plug in 3 to that function, 4 minus 3 gives me a 1. Okay. All right, let's do a couple more until we get it. So again, it's all about just deciding what function to plug it into, and we do that based on those restricted domains. So those numbers on the right of the function are going to tell us everything we need to know. Okay, so on the bottom here, I have h of -5. So I'm going back to my h function since it's h of x. So we're going to use h of -5. Now we just have to decide, does that go into the top equation, the middle equation, or the bottom equation? So let's take a second and think about that. Where was -5 fit in these restrictions? Okay, well, -5, if we look at this, is -5 less than 2? Well, yep, it is. So we're using that top equation then, that x squared equation. So if I plug in -5, we get -5 squared, which would be positive 25. -5 times -5 gives me positive 25. Okay. Okay, a couple more. Let's do h of 0, or sorry, f of 0. F of 0. So we're back to the f function since they're asking us to find f of 0. So if I'm going back to the f function, I have 2 equations to choose from. So if they gave me 0, is 0 less than or equal to 0, or is 0 greater than 0? So this one's kind of tricky because 0 is equal to 0, right? So that means we're using the top equation. So be on the lookout for those equal to's because they're going to help you. So that means we're using the 2x plus 3 equation. So if I plug my domain value into that function, 2 times 0 plus 3, I get 0 plus 3. Final answer, 3 on that one. Okay. All right, let's do one last one together, and we're going to look at h of 4. So h of 4, do I plug that into the f of x function or the h of x function? Okay, hopefully you realize you matched h with h, so we're using the h of x function. Now we just have to decide, where does 4 fit in? Which function am I going to use there for h of 4? So look at the restrictions. Is 4 less than or equal to 0? No, right? Is 4 between 2 and 4? Well, technically, yes, but this is just saying strictly less than 4. But 4 is equal to 4, so it's not going to work in that one. So it's going to fit into this last restriction here where it says x is greater than or equal to 4. So that's the function we're going to use. We're going to use the absolute value of x minus 2. So plugging in my number, 4 minus 2 is 2. Well, the absolute value of 2 would still be 2. Remember, absolute value makes your answer always positive. So if it was negative, we would switch it positive. But since it's positive, it just stays that way. So again, the important takeaways is just making sure you're only ever plugging into one equation. You use the restrictions on the domain to tell you which one to use. Okay, so you guys are going to try this one. So I have 3 functions here for this function g of x. So g of x is -4 if x is less than -2. 3x plus 2 if x is greater than or equal to -2 but less than 4. And then use x plus 4 if x is greater than or equal to 4. So start with finding this first one. What is g of -4? Okay, so the answer I got was 16. So hopefully you got that answer. Let's try the next one. G of 0. Where is g of 0? Well, hopefully if you had 0, you plug that into the middle function because 0 would be between -2 and 4. So 3 times 0 plus 2 gives me 2 as an answer. Okay, last one. Find g of 4. Okay, 4 is equal to 4, so hopefully you plug this into the last equation. 4 plus 4 is 8. Okay, that is everything so far on evaluating piecewise functions. So eventually we are going to be graphing these functions, but first, before we do that, we do have to know how to evaluate them. So all it is some plug and chug. You just got to plug the value into the right equation and then make sure you do your arithmetic correctly. But again, make sure you're only ever plugging into one equation. Compare your value they give you with the restrictions, and it should tell you which equation to plug into. Okay, we'll see you in the next video for graphing.